Top Secret Sci-Operative Training Mission. Reading Passage. The Tyndall Effect. Mission: understand properties of mixtures and how to identify different types of mixtures. Tips: remember to beam as you read through the passage below. I don't know if we are going to be able to make it all the way to the hive base, Dr. Noble. The fog is making it impossible to see.
I better pull over, Zia. We won't be able to see until the fog clears.
Can't you just turn the bright headlights on? That would make it easier to see.
That will actually make it worse. The light is bouncing off water vapor in the fog. Air is a homogeneous mixture, meaning it is a well-mixed mixture that is even in composition. It's a mixture of nitrogen, N2, oxygen, O2, and a bunch of other gases, including water vapor, H2O. If you turn the brights on, it will just make more light scatter, and it will be even harder to see.
The composition of air includes 78% nitrogen, 20% oxygen, 0.03% carbon dioxide, and other gases, 0.97% inert gases, which are mainly argon, and 1% water vapor. We see these percentages reflected in the particle diagram of air. If that's true, why do headlights normally help you see if water vapor is always there?
Air is normally an example of a solution, which is a special type of homogeneous mixture that is transparent because it has very small particles. Solutions have a solute mixed evenly into a solvent. The solvent is the part of the mixture in the highest amount that is able to dissolve the solute, which is the substance found in smaller quantity being mixed into the solvent to make a solution. Solvents are most frequently liquids, but can be any state of matter. In air, nitrogen gas is a solvent because it makes up 78% of the mixture, and solutes include oxygen, water vapor, and other gases that make up the rest. Since air is a solution, the light can travel very far and help you see objects more clearly. Fog is actually a different type of homogeneous mixture called a colloid, or a mixture with suspended particles that can scatter light. In the case of fog, the light from the headlights bounces off the suspended water vapor, thus scattering the light in all directions.
You can see in the diagram to the right that a beam of light passes through a solution particle and scatters it when it hits a colloid particle. Notice that the colloid particle is larger. This will be important later. If water vapor is already present in air, how does it form a colloid?
While you are correct that water vapor is always present, fog only forms if there are three things present at the same time. First, you have to have some kind of air pollution or dust. Second, the air needs to be humid and have more water vapor than normal. Third, the temperature has to get colder, which is why fog is most often seen in the morning when temperatures are at their lowest point. When all three things are present, the water vapor in the air condenses, or goes from a gas to a liquid, as it sticks to the air pollution. This forms clumps of water and pollution that become visible to the naked eye.
No wonder it's so foggy close to the hive's base. The hive's pollution machine is putting a ton of air pollution in the air. If fog is a cloud, though, why doesn't it rain when it's foggy?
It isn't cold enough that close to Earth's surface. When you go higher in the atmosphere, it gets colder. So more water vapor molecules condense, forming even larger clumps of water and pollution. Once they get large enough, then the force of gravity is strong enough to pull them down to the Earth's surface as rain. At this point, it's no longer considered a colloid, but is now a suspension. Suspensions are types of heterogeneous mixtures that have particles large enough to be seen with the naked eye, that separate out of a solution over time. Suspensions are a kind of heterogeneous mixture, which have visibly different parts and may have substances in different phases of matter.
How can you tell if something is a colloid or a suspension? Is there a test you can do?
Yes, there is. We are doing one of the tests now with the headlights. You can take a flashlight or laser beam and shine it on the sample. If you cannot see the light beam in the sample, the particles are too small to scatter the light, and the sample is a solution. If you can see the light beam in the sample, the particles are large enough for the light to bounce off of, and the sample is a colloid or suspension. Just like the headlights in the fog. This scattering of light by particles of a certain size is called the Tyndall Effect.
We can see the Tyndall effect in action in this diagram. When the flashlight shines, you can't see the light in the solution, so it is invisible because the particles are dissolved. This means the Tyndall effect is not observed. In the colloid, the flashlight beam is visible and the particles are evenly mixed. In the suspension, the flashlight beam is visible and some of the particles have settled to the bottom. This means the Tyndall effect is observed for colloids and suspensions. If the Tyndall effect happens for both colloids and suspensions, how can you distinguish between them?
Like with a raindrop, particles in a suspension will fall out of the mixture because they are so large. If a mixture sits for a while, the particles will separate out from the sample, meaning that it is a suspension instead of a colloid. Particles in suspensions are also too big to go through filter paper, so filtration will separate the particles from the rest as well.
Is there any way to tell what kind of mixture something will form before you mix it?
That's a great question. Unfortunately, you have to mix it and see what happens. If you happen to know the size of the particles, you could guess what mixture would form. Solute particles are so small that they are dissolved in a solution and are invisible to the naked eye. The particles in a colloid are larger, but light enough to stay suspended and cause the Tyndall effect. The particles of a suspension are the largest, and therefore separate because they are pulled down by gravity.
Comparing particle size. Solution. The particle size is below 1 millimeter in diameter. Colloid. The particle size ranges from 1 to 100 millimeters in diameter. Suspension. The particle size is above 100 millimeters in diameter. I want to see what happens when we mix with the hive in battle and I try out my upgraded EMAG gadget. They won't stand a chance against me. It looks like the fog is clearing. Let's go find some aliens. Make connections. In each box below, write a connection between the text that you just read and either your prior knowledge or something in your life. Reading comprehension questions. The Tyndall Effect. 1. Fill in the diagram below to compare and contrast homogeneous and heterogeneous mixtures. Write in information for homogeneous mixtures on the left side of the Venn diagram and information for heterogeneous mixtures on the right side of the Venn diagram. 2. For each of the following, identify if a solution, colloid, and/or suspension is being described. A. It has particles that settle out over time. B. It has a solute and solvent. C. It has particles 1 to 100 millimeters in size. D. It is a homogeneous mixture. E. It causes the Tyndall effect. 3. The beaker shows the particles in a solution. A. Label which particle is the solute and the solvent. B. Describe how you determined which to label. C. If you were to shine a laser pointer at this beaker, would you observe a beam of light inside? Why? 4. Explain why car headlights provide more assistance on a clear night than on a night with fog. In your explanation, include the terms homogeneous mixture, solution, colloid, and Tyndall effect. 5. After the fog cleared, the PsyOps team spotted a layer of slime on top of a stream running through the hive base. Would this be an example of a solution, colloid, or suspension? Explain your reasoning. 6. The table below shows experimental results for 2 samples of mixtures. Based on the results provided, write in the particle size range in the last column.